We all know what velocity is. We all know what speed is. So I'm not going to explain what is velocity or what is speed, because we know speed is the rate at which a body covers the distance. But the distance covered in a particular time is called its speed. And you know the basic formula of speed and velocity, that is distance by time for speed, and for velocity we use displacement divided by time. The basic difference between speed and velocity is that speed is a scalar quantity, whereas velocity is a vector quantity. The formula remains same, the SI unit remains same, but the main difference is of scalar and vector quantities. The scalar quantities does not have any direction but only magnitude, but vector quantities have magnitude as well as direction. The topic that I'm going to explain you today is instantaneous velocity. This is, as the name suggests, instant. Instant means at any particular instant. So the definition goes like this: it is defined as velocity of a particle at any instant of time. See, velocities are of mainly two types that we know. That is uniform velocity and one is non-uniform velocity. Uniform velocity is when the velocity is not changing with respect to time. The body is moving continuously in one speed only. Then it is instantaneous velocity. But if the velocity is changing with respect to time, then it becomes non-uniform velocity. The third type of velocity is instantaneous velocity. It is defined as velocity of a particle at any instant of time. So the formula of instantaneous velocity is dx by dt. Now you all remember what is dx, what is dt. This was explained in mathematical tools when we learned how to do differentiation. So d by dt means differentiation with respect to time. T here is time, and you have to remember what x is. X is the displacement. X is equal to displacement. So with help of this formula, we can find velocity at any particular interval of time. I will just give you a sample problem by which we can understand how this formula help us to find velocity at a particular interval of time. So the question goes like this: displacement covered by a body is given by s equal to x square plus x plus 4. Find its velocity at t equals to 2 seconds. So here you have a equation for displacement and you have to find velocity at time interval 2 seconds. So this velocity is the instantaneous velocity because it is asking for velocity at that particular time. So the formula is dx by dt. So you know the formula for that instantaneous velocity. We have v is equal to dx by dt. But here we don't have x, they are using the symbol s. The question can use any symbol for displacement: x, s, even a, any symbol. So you can change the symbol according to your given question. It becomes ds by dt. Now if you differentiate s with respect to t, the question should also be in terms of t only. So this is not x square plus x plus 4, it is t square plus t plus 4. So when you differentiate it, what you get? You get twice of t plus t becomes 1. You know differentiation of x was 1. So differentiation of t becomes 1 and constant is 0. So what you have? 2t plus 1. Now you have to find velocity at time interval 2 seconds. So how you have to write? ds by dt. Make a bracket over here like this and write t is equal to 2. This is the way that you have to write. So when you substitute 2 in place of t, what you get? 2 multiplied by 2, 4, 4 plus 1, 5. So answer to this question would be 5 meter per second. And this is the way you have to solve questions related to instantaneous velocity. Like the term instantaneous velocity, we have one more term, that is instantaneous speed. There's not a much difference again. The basic difference remains the same, that one is scalar and another is vector. So definition would change. It is defined as speed of particle at any instant of time. The formula remains same, dx by dt, but x becomes distance in case of instantaneous speed. So when we have displacement, it would be contributing to velocity, and if we have distance, it would be contributing towards speed. So the formula remains same, and the way of solving the question remains same in case of instantaneous velocity or instantaneous speed.